Record. So this is going to be question 5 of the October 2020 Pure 2 maths paper. So just going to go through how to do this one. So the curve with equation y equals 3 times 2 to the x meets the curve with equation y equals 15 minus 2x plus 1, the point P. Find using algebra the exact coordinates, x coordinate of P. So basically, in general, when we do questions where there's two curves that meet each other, so this is a curve, this is a curve, we generally want to set them equal to each other if we're trying to find the coordinates of where they meet. So, for example, we're going to say 3 times 2 to the power of x is equal to 15 minus 2 to the power of x plus 1. Okay, so this is the first step. And essentially what we need to do is we need to get this in terms of x. So try and isolate all the x's in one place so we can solve for x. So one thing you might be tempted to do, which we can't do, is we can't combine this 3 and the 2, because some people might go, 3 times 2, that gives me 6. That's not something we can do. We can't mix this 2 to the x with this 3. Okay, so this 3 is like the coefficient. It's a bit like having a 3x. You can't combine them anymore. It's just a 3 in front of the x. So what we do from here is we're going to, keep the left-hand side as it is for now. And we're essentially going to change the right-hand side. And we're going to change it by doing 2 times 2 to the x. And the reason that this works is because 2 is essentially 2 to the power of 1. And when you multiply two terms that have the same base number, so the 2, you add the exponents. So x plus 1 gives you 2 to the x plus 1. So what we can do now is we can actually bring the terms with the 2 to the x onto the same side. So I'm going to go 3 times 2 to the x plus 2 times 2 to the x is equal to 15. And then what we can do is we can take 2 to the x out as a factor. So 2 to the x, and then we have to multiply by 3 to get 3 times 2 to the x. And we have to multiply by 2 to get 2 times 2 to the x. And that's going to equal 15. And then from here, we can say, well, 2 to the x times 5 is equal 15. And then from there, we can say 2 to the x is equal to 15 over 5, which is going to be equal to 3. So 2 to the power of x equals 3. So we can actually take the log of both sides now, which will give us log 2 to the x equals log 3. And then if we follow the log law, we can take the x down to the outside. So x log 2 is equal to log 3. And then therefore x equals log 3 over log 2. Now you could have done a slightly different approach to this as well. You could have taken a log to the base 2. So I just took a generic log. Doesn't really matter what this log base is as long as it's the same between the two. So what you could have done instead, and I think what's in the mark scheme for this particular question, is to say, what is it? It's going to be log 2, 3 is equal to x. Because essentially, if we read this log law, it essentially says 2 to this power is equal to what's inside the bracket. So it's a bit confusing looking at it like this, but the example that I always use to convince myself is this. If you take log to the base 10 of 100, you will get 2, because 10 to the power of 2 is equal to 100. So it works the same way here. 2 to the power of x is equal to 3. So you could actually do it either way. You can do it as this, or you can do it as this. It's up to you.